a tots. Bé, en primer lloc, el que volíem fer era agrair des de la Càtedra UNESCO la presència de totes les persones que, de vosaltres, que avui ens acompanyeu en l'inauguració d'aquest cicle de seminaris que la Càtedra UNESCO, la nostra per la gestió empresarial i el medi ambient, ha organitzat amb l'objectiu de mostrar com l'anàlisi econòmica pot contribuir a la ciència de la conservació ambiental. Conscient de la necessitat de dissenyar polítiques locals i nacionals encaminades a la protecció dels ecosistemes marins i costaners, en un context de continus impactes ambientals que s'espera s'intensifiquin amb el fenomen de l'encalentiment global, la càtedra el que fa avui és iniciar un cicle de seminaris titulat "Què val la conservació marina, la contribució de l'anàlisi econòmica a la ciència de la conservació ambiental". Amb aquesta iniciativa es vol mostrar com, a través de la identificació i valoració de costs i beneficis associats a polítiques, projectes i o programes implementats en el marc d'ecosistemes marins i costaners, la valoració econòmica pot contribuir a fer més eficients socialment els processos de presa de decisions en un intent de garantir la sostenibilitat d'aquests recursos naturals. Així, en aquest cicle de seminaris es parlarà de diferents àmbits de gestió que poden beneficiar-se de la informació proporcionada pels estudis de valoració econòmica. El disseny d'àrees de protecció marina, de programes de control de l'erosió, d'estratègies de preservació de la biodiversitat marina i de plans de preservació del patrimoni marítim i pesquer, així com l'avaluació de danys ambientals i de projectes d'infraestructures de producció d'energia en són alguns exemples. El paper de la valoració econòmica és encara més rellevant en un context en què els estats membres han de seguir les directrius marcades per la política europea de l'aigua per tal d'assolir certs estàndards de qualitat i les polítiques ambientals exigeixen cada cop més cercar l'equilibri entre els beneficis i els costs de les regulacions. El cicle de seminaris que avui inaugurem, però, no només vol posar de manifest la contribució de la valoració econòmica dels serveis dels ecosistemes costaners i marins a la ciència de la conservació ambiental, sinó també vol remarcar la importància, la necessitat i sobretot la responsabilitat que tenim els economistes ambientals de col·laborar amb els investigadors que centren la seva recerca en diferents àrees de les ciències naturals. La informació... I és que el coneixement ecològic pot, entre d'altres, ajudar-nos a modelitzar les amenaces específiques a què s'enfronten els ecosistemes marins i costaners i proveir-nos d'informació biofísica com la representativitat i la connectivitat, essencial per identificar àrees de protecció en els processos de presa de decisions que cerquen la conservació ambiental des de l'eficiència social. La informació proveïda per les ciències naturals pot ajudar-nos també a entendre com els serveis oferts pels ecosistemes marins i costaners es generen a partir de processos i funcions biofísiques i ens pot aportar també coneixement sobre la incertesa ambiental que podem utilitzar després per analitzar-ne els seus efectes sobre el valor social de la conservació marina. En definitiva, el coneixement ecològic ens pot ajudar a quantificar millor el valor econòmic que atorguem a les grans quantitats de serveis que ens ofereixen els ecosistemes costaners i marins. Així doncs, podem dir que amb aquesta iniciativa, la Càtedra UNESCO, la nostra per a la gestió empresarial i el medi ambient, cerca promoure la col·laboració entre les ciències socials i les ciències naturals tan i tan necessària per a resoldre els problemes ambientals d'avui. En aquest sentit, es presentaran al llarg d'aquest cicle alguns exercicis de valoració econòmica al voltant de la conservació de la biodiversitat marina per tal de mostrar-ne la demanda social i es farà un repàs a la valoració econòmica dels serveis proveïts pels ecosistemes marins i costaners durant el segle XXI des d'una perspectiva de gestió. Avui gaudirem del primer seminari titulat Valuing the Conservation of Biodiversity in the Deep Sea a càrrec del Dr. Hanley, catedràtic d'Economia Ambiental a la Universitat de St. Andrews, a Escòcia. El doctor Hanley ha publicat més de 150 articles a revistes especialitzades i té una àmplia experiència en l'aplicació de l'economia ambiental, el disseny i l'avaluació de polítiques ambientals, especialment pel que fa als mètodes de valoració econòmica i a l'anàlisi cost-benefici. Ha dirigit equips de recerca interdisciplinaris que han treballat en projectes a gran escala, tant en el marc del programa Rural Economy and Land Use, cofinançat conjuntament pel Consell de Recerca sobre Medi Natural i el Consell de Recerca Econòmica i Social del Regne Unit, com també al voltant del Value Nature Network. El professor Hanley ha estat també coinvestigador de projectes finançats pel Consell de Recerca sobre Medi Natural entorn de la valoració de beneficis associats a millores de la qualitat d'aigua a Escòcia. Actualment treballa en diferents projectes en el marc del programa Tree Health and Plant Biosecurity, finançats pel Consell de Recerca en Biotecnologia i Ciències Biològiques. Dirigeix també el Fòrum de Coastal Zone del Consorci Marine Alliance for Science and Technology for Scotland i és membre del Comitè d'Assessors Científics del Marine Scotland i del panell d'assessorament econòmic i social és membre del Comitè d'Assessors Científics del panell d'assessorament econòmic i del Departament Britànic de Medi Ambient i Afers Rurals. El professor Hanley també val a dir que ha estat assessor de l'Agència de Protecció Ambiental Escocesa, així com de l'Agència Ambiental Britànica. Així que anem a donar la paraula al doctor Hanley i després obrirem un torn de preguntes perquè tots aquells que vulgueu pugueu fer-li aquelles qüestions que pot semblar d'interès. Bé, per la nostra part esperem que gaudiu tant com ho farem altres d'aquests dos treballs que ens han presentat Nick. So Nick, please, all yours.
Oh, okay. Good. Well, thank you for coming along today. And yeah, my name's Nick Hanley. I'm from the University of St Andrews in Scotland. And Cathy asked me to talk about some work I've been involved in recently on valuing the economic benefits from conserving biodiversity in the deep sea. And so that's what I am going to talk about. But actually, the methods that we use here, you could use to value biodiversity in any kind of ecosystem. So you could just delete the words the deep sea and you could replace those with forests or wetlands, and you would still learn something, hopefully, from what I'm going to talk about. But my examples are going to come from some work in the deep sea, because thinking about the deep sea, whether it's off the coast of Norway, like in this picture on the left, or off the coast of Scotland, like in this picture on the right, imposes certain challenges on us in terms of thinking about how we put economic values in euros on the benefits of protecting biodiversity in the deep sea. But anyway, if people want to ask questions as I'm talking, that would be great. So just interrupt. And Cathy tells me that there's only 4 people who are economists here. Is that right? That's great. Only 3 people who are economists. That's even, well, I know it, me as well, okay? I think. So I've tried to avoid every piece of economic jargon, but I may have failed. So if I say something you don't understand, please tell me, okay? So let's see how this works. I think this probably works like this. Yeah. So I usually start by challenging my students to try and answer a very simple question in biodiversity conservation, which is, why should we bother? So what is the point of spending money to protect endangered species? So here, for example, thinking about dolphins or seals around the coast of Scotland, what's the point in trying to conserve ecosystems like wetlands or seamounts or forests? And what I want to talk about today is that the idea that one of the main reasons that we could give for protecting biodiversity is that it gives us economic benefits. Now, obviously, that's not the only reason for protecting biodiversity, and it's probably not the most important reason for protecting biodiversity. But sometimes it's a very persuasive reason. And if a conservation scientist is arguing with a developer or the Ministry of Finance about why it's important to protect biodiversity, then often it's helpful to be able to say there are real economic benefits in protecting biodiversity. So I'm just going to, first of all, outline why economists think protecting biodiversity is economically valuable, and then very, very briefly tell you about some tools for measuring those values. But then most of what I'm going to talk about is a series of case studies where we apply these tools to the deep sea. or to marine environments. I think in one case, I couldn't really call it the deep sea, because it's the North Sea between the UK and the Netherlands, and it's not really all that deep. But it is definitely a marine environment at the moment. So, and then finally at the end, just think about how we could use these kinds of values in policy making or in environmental management, and also what some of the problems are in trying to measure these values. And I think we can use these techniques to value all kinds of environmental resources and all kinds of environmental changes. So the kinds of methods I'm going to talk to you about, we could also use to value changes in air pollution or in noise around airports. But in valuing biodiversity, we often push these techniques to their limits. And so thinking about those limits is kind of interesting. So no questions so far, right? Okay. So I should say also that, if you ask an ecologist, what do you mean by biodiversity? They would have many different answers for you. Most of the economic work on valuing biodiversity has actually been about valuing particular species or the number of species in an ecosystem. Or it's been about valuing habitats, like the benefits of conserving a forest. There are very few studies which have been about other definitions of biodiversity. So most economic studies are about either conserving species or about conserving habitats. And the main problem that all of these studies have is that if we go to a financial newspaper, or we turn on a financial news channel on the TV, and we say, okay, let me see if I can find the value of biodiversity today, it's not there, right? We can see the value of oil, or we can see the value of shares in BP, but we can't see the value of biodiversity. And that's because many of the benefits we get from biodiversity are not priced by markets. So as economists, we're trying to fix that problem, essentially. So in trying to fix that problem, we have to think about how might biodiversity be of value to people. Because in economics, going back more than 200 years now, when we think about how do we define value, we always think about it in the terms of value to people. So how does conserving biodiversity relate to your well-being? And we could imagine really there are two ways in which that happens. And the first way is simply people care about aspects of biodiversity. They care about nature. So if I tell people that I am going to conserve particular species like sea eagles or dolphins or whales or coral reefs, that makes them happier. So their well-being goes up. And that's a very direct benefit from conserving biodiversity. So simply by conserving species or protecting forests or protecting wetlands, we make people happier. And those direct values are economically important, even though they do not show up in any kind of market price or market value. But we could also think of a less direct way in which biodiversity has economic benefit, or protecting biodiversity has economic benefit, and that's an indirect approach. So maybe through conserving ecosystems, we conserve the inputs that they provide to goods and services which we consume every day. So by conserving coastal wetlands, we also conserve fish populations which we can then go catch. Or by conserving wetlands, we also provide flood defense or pollution treatment facilities. Or most obviously, by conserving soil, we maintain the capacity to produce food. So those are kind of indirect values of biodiversity or ecosystems. So they don't benefit us directly in terms of our well-being, but they benefit us indirectly through their effect on the production of goods and services which we buy in markets. And as economists, what we try to do is basically add up both of these kinds of values. So the direct benefits of biodiversity and the indirect benefits of biodiversity. But, as I've said, in both of these cases, the marketplace, the Financial Times, or what's the financial newspaper in Spain? If you want, Kathy, when you want to check your shares, what do you look at?
Well, for instance, this is the economic section of El País.
Okay. There's no listing for eagles in there, right? We would agree with that. There's no listing for coral reefs or seagrass meadows. So that's the problem, right? We can't go look it up. If we want to check how wealthy Kathy is, she can go and look in these financial pages and she can see her shares are worth 3 million euros. But we can't check how valuable the biodiversity around the coast of Mallorca is through doing the same way. So we have to think of other ways of measuring these values. And I'm not going to go in this in any kind of detail, but I just want to mention that there are a number of approaches we can take. So sometimes we can look inside of markets and we can find signals about the benefits of protecting biodiversity. And that's most obviously true if we think either of medicines, drugs, or food production. So you can imagine that it might be possible to say that by conserving rainforests, we might be protecting the opportunity to develop new medicines. And medicines sell in the market, so there's a value for biodiversity. Or you might also think that by protecting the genetic diversity of wheat or barley or rice, we're able to engineer new varieties which are more resistant to drought or more resistant to disease. And that's got an economic value because we can sell those. But most times we can't do that. And so what we do is we try and think about the two main economic measures of value of anything, whether it's biodiversity or cars or houses. And those two measures are, first of all, what's the most that someone's willing to pay to have that thing? Or what is the minimum compensation I would have to give them to take it away? So we're very used to thinking about those concepts, for example, in an auction. Okay? If we were going to auction Kathy's car, we could say, what's the economic value of her car? It's the most someone's willing to pay for it, or it's the minimum price that she would accept to sell it to you. But actually we can apply exactly the same kind of reasoning to biodiversity, which seems kind of crazy, but that's exactly what we do. And how do we do that? Well, what we're trying to do is measure essentially three kinds of benefits that people might get from, let's say, protecting an ecosystem. So let's imagine we were trying to estimate the economic benefits of creating a new marine protected area. We might say, what kinds of benefits would we try and measure here? Well, what we try and measure is essentially three kinds of value. And the first would be to people who are going to use this marine protected area. So this might be people who go diving there and can see all the biodiversity in the water. Or people who go recreational fishing there, sea angling. Or people who just like to watch wildlife from their boats. So these kinds of benefits, in terms of what people are willing to pay for them, are something we would try and measure. But then we might say, well, there may be many people, let's say in Mallorca, who care about the protection of marine or coastal environments, even though they never go there, even though they never go diving or recreational fishing. They're still willing to pay something for its conservation. And we call these non-use values, and we'd like to try and measure those as well. And they turn out to be very important for rare or endangered species, for example. And then finally, we might recognize that in protecting a marine ecosystem or a coastal ecosystem, we're actually going to generate allow that system to produce a number of different services, ecosystem services, which are valuable to us. So that might be, if we set up a marine protected area, then all around the edge of this area we have a higher fish catch. So that's a service. Or it might be, by protecting seagrasses, we have more carbon sequestration. So that's an economically valuable service. Or it might be we improve nutrient cycling or sediment removal. All of these are valuable services. And so we'd like to try and put a euro value on all of these. And as you'll see in some of the case studies at the end, that's exactly what people try and do. So how are we going to do that? We've got some tools in our toolbox. And we basically have three kinds of tools. And the first kind of tool are called stated preference methods. And those are survey-based methods which basically try and directly figure out what are people willing to pay to protect the environment. So to establish new marine protected areas or to protect forest areas, what are people willing to pay for that? How much of their income will they give up to have this biodiversity conservation? How can we measure that? So we have a number of different methods. One method is called contingent valuation, very famously used to look at the economic costs of big oil spills in Alaska and in northern Spain. And another method called choice modeling, choice experiments, comes from market research. I'm going to show you some choice experiment examples later, so I'll leave that one for the while. But we have another kind of tool which is called revealed preference methods. And there we look at people's behavior which is somehow related to the environment. So if we wanted to say, what's the economic value of scuba diving or beach access, we could say, well, people don't pay a price to go to the beach, but they do incur costs of traveling. So maybe we can see some relationship between how much money people are willing to spend to go to a beach or a national park and the environmental quality of those beaches or those national parks. And if we can do that, then we can figure out an economic value for the benefits to them of being able to use beaches or national parks in a particular environmental condition. So these are called travel cost models. And for example, we've used them to estimate the benefits of national parks in Scotland to rock climbers. And then we could also say, well, maybe the housing market tells us something about the value of environmental quality. For example, we might say people are willing to pay more for houses in less polluted areas or in areas with more green space. So we could relate somehow the value of environmental quality to the housing market. And that's called hedonic pricing. And then finally, our third kind of tool is called production function approaches. And there we're trying to link the quality of the natural environment to the production of something. So very famously, people have linked the protection of coastal mangroves in Southeast Asia to fisheries output, or link it to storm risks, or link it to deaths from tsunamis. So we're linking the protection of some ecosystem to some output through some kind of mathematical statistical function. And we can do that as well for a whole range of ecosystem services. So there are lots of tools out there. And not all of these tools can measure all of these three kinds of benefits, these use benefits and non-use benefits and ecosystem inputs. But we can use all of these tools to measure aspects of these three kinds of benefits. So they're all kind of useful. Now, if I was giving a talk about valuing biodiversity in forests or anywhere on land, any kind of terrestrial ecosystem, there would be probably 100 different studies I could show you. If I was talking about coastal biodiversity, I might be able to show you maybe 30 studies. But when I think about the deep sea, I can find almost none. And so, given that we use the same methods to apply to valuing any kind of biodiversity, you might say, well, why would that be? You know, maybe the deep sea is just not very interesting, or nobody cares about it. Or maybe it's just more difficult to use these kinds of methods there. But why in particular do we think it might be? So when I say the deep sea, what I mean, as you will know, I'm sure, is areas deeper than 200 meters. So this is about 90% of the world's ocean areas. So this is like a very significant part of the world's marine resources. But when we think about applying these kind of economic valuation methods to the deep sea, we immediately think of two kinds of problems. And the first kind of problem is that ordinary people know very little about the deep sea. If I ask people what they're willing to pay to protect vultures in Mallorca, they say, okay, I've heard of a vulture. I can see a vulture in the sky. I can think about how much I care about that vulture. That's not so hard to value. Or if I ask people how much they're willing to pay to protect traditional olive groves in the landscape, they know all about those. But when I ask them what their willingness to pay is to protect deep sea mounts, or to stop oil and gas exploration in cold water coral areas, well, they've never heard about these areas, and what's more, they can't go there. It's dark, it's too deep. But the second kind of problem is we also have very poor scientific knowledge of the deep sea compared to terrestrial systems. So if I want to apply these production function approaches to the deep sea, then that's quite difficult, because when I say to my marine science colleagues, okay, tell me the function that relates conserving this particular ecosystem to nutrient cycling or carbon sequestration, then they might well say, well, we don't really know much about that. Whereas in the terrestrial environment, we would know much more about it. And when it comes to biodiversity, one major problem we have with the deep sea is we just don't know how many species are down there. So this number comes from a survey paper by this guy Kozlow, 2007, and I'm not sure if this is right. Maybe you can tell me. But according to this guy, the best guess as to the number of species in the deep sea is somewhere between 500,000 and 100 million, which seems quite a big range, really. And that only 3% of the sea floor is mapped in the public domain. Okay, so military intelligence knows a lot more about the deep sea than ordinary scientists, I guess. So there are these two problems then. There's a scientific uncertainty, but there's also a lack of knowledge by the general public. And so what we would conclude is that valuing biodiversity changes in the deep sea is going to be pretty difficult. But, of course, economists being crazy people, they like to try and do this anyway. And so Claire Armstrong, who's at the University of Tromsø in Norway, who I work with, she's got this very nice paper in the journal Ecosystem Services in 2012, where she talks about the kinds of values we would get, economic benefits from protecting the deep sea, and how we might try and value these benefits. And she talks about both biodiversity and ecosystem services across a whole range of deep sea ecosystems. But she doesn't actually try and do it in this paper. So there are a number of papers which do try and do it. I'm going to talk to you about some choice experiments which I've been involved in working on. So one is in the North Sea, one's in the sea around Scotland, and one's off the Norwegian coast. There are some other studies which, for example, Claire Armstrong's own work, trying to link conservation of seamounts to deep sea commercial fisheries. And there's also some more descriptive work, which one of my old PhD students did. We published that in PLOS ONE in 2014, where we basically tried to use expert scientific knowledge about what these ecosystem services were worth to value conserving them. But mostly, what's out there is a number of choice experiments. So I really need to briefly tell you what a choice experiment is before we go on. So here's one of the three examples I'm going to show you. So this is one of my PhD students, a guy called Niels Jobsvogt. He got his PhD last year. And we published this paper in Ecological Economics. And Niels was a marine biologist. That was his training as a master's student in Germany. And then when he started his PhD jointly between myself and Ocean Lab in Aberdeen University, he decided he wanted to do some economics. And in fact, he ended up writing all of his papers on economics, which really annoyed his other supervisor because she was kind of hoping to publish some nice deep sea biology stuff, but he didn't find that so interesting. So what Niels tried to do was answer the question, what are the economic benefits of protecting deep sea ecosystems around the coast of Scotland? And to do this, he used a choice experiment. So in a choice experiment, what we're trying to do is estimate what the general public or recreational users of an outdoor area or people who live in a specific city, what are their preferences for, what's their willingness to pay for protecting or improving the different characteristics of an environmental resource. And the environmental resource we're going to look at here is marine protected areas in the deep sea. And we're going to describe this resource in terms of the effect it has on biodiversity conservation. And the people who we're sampling, our population that we're sampling, is the general public in Scotland. So these are Scottish households. So what we did was we designed this choice experiment, and it revolves around the current situation, which is that if we go back to this map, so these dark blue areas, this is the deep sea around Scotland coast, so the green is the shallower marine areas. So currently 1.5% of Scottish waters are protected, either in terms of excluding fisheries or in terms of also excluding oil and gas exploration. So those are essentially around a place called Rockall. And that's been designated as specifically valuable in terms of its biodiversity. And in our protection scenario, what we talked to people about was the possibility of increasing this protection from 1.5% to 6%. So relatively speaking, it's quite a big increase, but it's still protecting a very small part of all of Scottish deep sea waters. And we were interested to know whether people would value this differently according to who would pay the costs of the exclusion. So in one scenario, we told people that the only industries excluded would be fishing. And then in another sample, we told people that fishing and oil and gas exploration would be excluded. And then we were basically interested to test statistically, is there a difference in the value I get from protecting biodiversity according to who pays the costs? So in a choice experiment, as I said, what you do is you describe what you're trying to value in terms of its attributes or its characteristics. And here we just have a very simple design with 3 attributes. One is the potential for new medicinal products from deep sea organisms. So we told people about the fact that a number of new medicines have been developed from things we've found in deep sea areas, and that might happen again in the future. But we were very uncertain about the potential for this. And the second attribute is how many species could we protect? And we said currently we think there's about 1,000 different species that live in this protected area. And these include things like fish, starfish, anemones, worms, all kinds of strange creatures. But we could either increase that to 1,300 species or 1,600 species. So again, not very many, but a relatively big increase. And finally, we said to people that if we're going to do this, it's going to be costly to you. You are going to have to pay higher costs. And these costs are to administer and police this vast area of sea. And so we said the cost could be any of these numbers. And so what people filled out in their survey were these kinds of choice cards, where essentially you're choosing between 3 different policies that all have different costs. 0 if it's business as usual, or a positive cost if it's to increase the area of protected areas, but where by paying some money, you get an increase in biodiversity conservation. And you get an increase in this value of new medicinal products. And so when we did that, okay, there's some very small numbers here, but you can read the paper if you're interested. I'll give you the references at the end. Basically, what we found was that even though people knew very little about this resource, the deep sea, they were willing to pay something to protect it. And so as a headline number, Scottish households were willing to pay something like £35 per year extra taxes to go from 1,000 species being protected in the deep sea to 1,600 species protected. And if we thought about the highest level of protection of our marine protected areas in deep sea, the benefit went up to about £70 per household per year. So that's about €80 per household per year. But interestingly, there was no significant effect, statistically significant effect, from which sectors were going to be impacted, whether it was going to be just the fisheries sector or also the oil and gas sector. And that's probably because in Scotland, very few people work in fisheries, and actually not that many people work in oil and gas either. So maybe that wasn't so surprising. So that's the first study I was going to use as a case study. The second one is something I was only commenting on. I didn't do this myself. This was done by a guy called Tobias Borger, who's at the Plymouth Marine Lab down in the southwest of England, down here. So he was looking at this area called the Dogger Bank. I don't know if anybody's ever heard of it. The Dogger Bank is an area of shallow marine waters between the UK, the Netherlands, and Denmark. And at that time, it was threatened by basically an increase in commercial fishing and the construction of a very large offshore wind farm. And so what they wanted to know was, what's the benefits of protecting this area from these two threats? More fishing and a very large wind farm. And so again, they used this choice experiment method. And I give you the reference at the end if you want to see, but in detail, but you can tell here they've got a very similar design to what we used. They've got different kinds of attributes. They've got the diversity of species, so that's just the percentage change in species diversity. They've got what happens to a specific group of species, which are porpoises, seals, and seabirds. They have an attribute related to the number of invasive species that increase, and that's because there's an idea that building offshore wind farms is a good way of increasing invasive species because you create a new habitat, and then again the cost to the household of creating a new marine protected area. And so here their sample is households in the UK, not Scotland. And again, lots of very small numbers. But what they found out was essentially the UK public was willing to pay significant value for protecting this area of the Dogger Bank. And the highest values for willingness to pay come from protecting what you might call charismatic species like porpoises and seals and seabirds. But they were also willing to pay to protect these areas from the spread of invasive species. So that's not really a deep sea, but it's definitely a marine example. Okay, finally, let me talk to you about the most difficult thing we did. So this is a project I've been doing with the University of Tromsø in the Arctic Circle in Norway. And they were asked by the Norwegian government to try and figure out what are the economic benefits of protecting a particular kind of ecosystem in the deep sea around the coast of Norway. And this ecosystem is called cold water corals. So like the coral reefs that you can enjoy on holiday in the Caribbean, I'm sure you will go to the Caribbean regularly, right? These coral reefs are more than 200 meters deep. You can't go swimming there, but they're incredibly important for biodiversity. And as Norway has been exploring for oil and gas around its coastline, it has found more and more and more communities of cold water corals. And so the scientists, of course, say we have to protect these incredibly valuable ecosystems, but the oil and gas industry says, no, no, we should be allowed to exploit these areas for profit. And so the Norwegian government wanted to know how many of these areas should we protect? And in particular, what are the people of Norway willing to pay to protect these areas? So again, we did one of these choice experiment things. But the problem was we were dealing with a good cold water corals, which most people have never heard about. So what we used was something called a valuation workshop method. So we undertook 40, roughly, workshops across the whole of Norway where we paid people to come to a room like this, roughly this many people, and we gave them a talk by some scientists about cold water corals and the threats to cold water corals. And then we asked them to undertake one of these choice experiments, and from that we could estimate what were the economic values to Norwegian people of protecting these cold water corals. So you can get a simple description of this survey in this paper that Margrethe Arnesen has published in Ecological Economics with me. And then we have a more kind of technical version in the Journal of Environmental Economics and Management, where we also make use of what we know about people's knowledge of the good. So again, we use these kind of choice cards. This is getting very similar now. So our attributes here were, first of all, how much of the Norwegian coastline are we going to protect from development? And secondly, it's, are we going to target those areas for protection which are less valuable for the oil and gas industry? Are we going to target those areas which are more important for biodiversity, measured by how good a habitat they are for fish, because there's big variation there? And finally, what's it going to cost you as a Norwegian household to pay for this protection? So these numbers are in kronas per year. And what we've, okay, there's lots of very small numbers here, but let me just jump to this. What we found again was a rather large willingness. So these are in euros now. Now obviously Norwegians are quite active and they care about the environment, but we were kind of surprised about how big some of these numbers are. But they do seem rather robust to the kinds of checks that we normally apply to these. So for example, it said that for the lowest level of protection, Norwegian households pay around about 200 euros per year to conserve these cold water corals around. So what I've shown you there, yeah. Yeah. I can hear you.
It's for the recording.
Oh, all right.
I know. No, my question is, of course you ask people after scientists have talked to them, but is it possible that there is some bias? I mean, to be honest, you should have both scientists and all about the benefits of this. So do you think it has an impact?
Well, that's hard to say because we didn't do a treatment with the oil companies talking. In fact, it was two scientists in Tromsø who were doing the talk.
Yeah, no, I'm about the ability of the scientists, but I was wondering, maybe they of how important are these habitats. So if you do the survey just the seminars, it's perhaps easier that they are positive towards.
Sure. So, good point. So if you read this more technical paper, if you want to, you'll see that what we did there was we actually did it twice. So what happened when you came into the room was we first of all gave you a test, a quiz. 10 questions about cold water corals, multiple choice. Okay? So everyone took the test, and then do the choice experiment, and we didn't, before we told you anything. And then we 15-minute lecture, I think it was 15 minutes. And then we asked you to do the choice experiment again. So we were trying to measure what effect does, what's the difference in telling me your willingness to pay based on your knowledge to the survey compared to how does it change if I tell you some new. And what we also did was for half, so this was really kind of nerdy economics, half the sample, we actually told them how well they scored in the test. If we told you that you scored above average, your willingness to pay went up. Pretty smart here. So, and statistically so. Whereas if we told you you scored less than the average, there was actually no effect. So that's paper. But yeah, absolutely. As I tell you more information, if you learn it, so it's not the same as you learning it, then clearly that might be to pay. That's how advertising works, right? So just to finish off, I just wanted to say two final things. One is, why would you want to do crazy valuation stuff? Because often when I ecologists and marine scientists about this kind of work, they say, yeah, but we know that it's important to protect coastal and marine ecosystems. We know it's important to protect biodiversity. Why do you need to ask people what they're willing to pay? That seems crazy. You try and answer that by saying, well, you know, there are actually ways in which one could make use of this information. And maybe the most important way, which some ecologists see, is motivating policy. So if you're trying to defend spending on biodiversity conservation or public research in biodiversity, being able to say, these crazy economists say that biodiversity actually generates real economic benefits is helpful. Whole global initiative called the Economics of Ecosystems and Biodiversity, TEEB, we're trying to get this message across at industry, at the level of government, at the level of local, that protecting biodiversity generates real economic benefits. It also generates costs, but it does generate benefits, and maybe that message doesn't often get through. For example, when I was giving a talk in Cyprus with the organization, they were most interested in this idea that now when the developers say another 6 hotels in the national park, they can say, well, okay, that's good, but so has protecting biodiversity. Another way you could is designing policy or improving the design of policy. What species should we be targeting for conservation? Maybe that should be the kind of species that people care about the most. Or in the area should we set aside as a marine protected area? What kind of technique can tell us something about that? And then finally, if you were just to say, okay, well, there are costs of creating a new marine protected area. Are these costs smaller than the benefits? Again, this is something that you could answer to some using these methods. But there are, of course, some big problems, particularly when we think about biodiversity and think about marine and deep sea settings. Firstly, in economics, we assume that ordinary people are the best judges of what's good for them. And so if somebody says, I don't care about biodiversity, my willingness to pay is 0, that's the answer I have to write down. And yet what we know, of course, is that people have very incomplete understanding of the way that biodiversity interacts with ecosystem services in terms of resilience, for example, or in terms of maintaining the value of those services. And maybe if they knew more, which is your point, right, then they would value it differently. And so that's an awkward thing we have to deal with. And maybe those aspects of biodiversity, let's say in the soil, which are most important, are also those aspects which ordinary people know very little about. So this is a very blunt, clumsy toolbox, really, that economists have. So it's important to remember that. Okay, so just 3 conclusions, I think. Firstly, I think benefit from recognizing the economic value of protecting biodiversity. Lots of examples of this in a variety of settings on land, at the coast, but right now, estimates in the deep sea for marine areas. There's also a lot of challenges. I've just mentioned a few. You know, when is it best to, when does it provide us with useful information? So listen, thanks for coming along. Those are the references. Do you want to keep, if people want these references? So these are the papers I'm talking about. Well, this one, this is just a survey paper, if you wanted to review. And that's me. Okay, thanks for coming.
I like very much the talk, but I would want to do the same with a species that people doesn't like very much. For instance, wolves or sharks, or that they suffer from the attacks of the animal.
So actually, there are quite a few studies on wolves. Maybe. So you can certainly use to look at the value of protecting wolves, for example. And what in Sweden have shown is you get very big differences according to where people live. So people in Stockholm are very happy to have wolves, but not in Stockholm, okay? Whereas if you ask people or something, they really don't. They would have it. So they would have a negative pay. They'd be willing to pay to get rid of wolves. Okay, and, that's fine because they don't like them. Okay, so we would certainly expect to see a very. There have been some studies done on sharks as well, and as you might expect, you know, big variations according to who you are, how you use. So maybe if you're a surfer or a diver, you have a different view than if you're someone who stays on the beach or goes out in a boat. But yeah, then you would be able to use these methods. In fact, one of my students is doing it for sharks right now over in Australia. But yeah, it's an issue, right? If people are afraid of, you could do it for mosquitoes, but what you would find, yeah?
Are there any times for the willingness to pay? Because obviously this will situations, for example, I'm just thinking about the increase in outdoor activities, which is now a lot of people going out far more to the mountains and stuff like this.
Yeah.
So obviously with more use, they might become more sensitized to, or more willing to pay more.
Yeah.
Similarly, with knowledge status, of course, if you're more, as you said before, if you're more aware of it, that will influence it.
Yeah.
At the same time, maybe a crisis like we just had might reduce the absolute value, while maybe the proportional value people are willing to pay might stay the same. And I wonder if it isn't quite interesting also to look at the temporal trends in these things, because I'm sure these are like a stock market will go up and down.
Yeah.
And,
yeah, you would hope so, right?
Interesting to see if this is true, because, for example, here in the island, there's far more people now going walking. I'm sure that this will affect the willingness to pay of tourists for these activities of these habitats and species. Yeah,
so we know that underneath these methods that there's some theory about what should affect your willingness to pay. So it should be things like your income and your awareness, your knowledge. So we expect that. And there are quite some studies now which try and measure this over time. Now the hard thing is always to measure exactly the same good or experience. So we've done some, for example, for forest conservation in Poland, where we've run exactly the same survey at different points in time. Maria Loureiro over in the University of Santiago de Compostela, she's done it for oil spills. So how much are people willing to pay to avoid to reduce the risks of oil spills along the coastline? And she's done that, I think, before the crisis and after the crisis. So she published that recently. And then on the travel cost side, when you're looking at the value of outdoor recreation, there are quite a few time series now which what is the value of a day in a forest over time or across income groups or between old and young. So yeah, for sure, you can do that. It's a good idea.
Sorry, it's just related to that, but in that case, it's obvious that you cannot value the same use over time because of the scarcity of the resource, right? Normally they are getting more and more scarce, therefore that has to have a very important impact, right, on willingness to pay, apart from other factors.
Yeah, but for example, if you looked in the UK, we've got quite a long time series on the value of a day spent in the forest, public forest, whether you're bird watching or just walking with your kids or whatever. So actually, over time, the number of forests has gone up, not down. But what really drives the variation in that is where people live, how that has changed, people's disposable income, how that has changed, people's leisure habits, how that has changed. So for sure. But as if you were looking at willingness to pay to protect, let's say, vultures, then over time that should respond to how endangered they are. So if suddenly they become very endangered, you would expect this number would...
So your example with the forest, for example, could be the reverse as well, as there's more protected forests and more people are enjoying the forest.
Yeah.
The more they care for the forest, the more they're willing to pay for it.
Yeah.
So it could not necessarily, rarity doesn't necessarily maybe determine the prices. I think it could also very much well be the positive influences or contacts I have with something.
Yeah.
So if I have a positive contact or have the possibility to have contact with things, then I might be experiencing something which is positive for me, and then I'm willing to pay for it.
Yeah.
So it's not. I don't think that necessarily rarity needs to be determining the price of my experience. You see what I mean? So for example, for a species that might work, but I think for other things it might not be so linear.
Yeah, it's probably not linear at all. And I mean, certainly if we come back to forests, what we have learnt, probably the most important thing we have learnt in the UK from doing all this work on valuing forest recreation, sorry, I'm sure you don't work on forests, but is that the best place to put a new forest is very close to a city, because then most people are going to go there. So the idea that the forests that are very far away, remote, beautiful are the most economically valuable for recreation is crazy, because very few people go there. Each person who does go has a very high value for it, but there's not very many of them. So,
I've got two questions. I think,
yeah.
for the talk. I've got two questions. The first one is, were the results of the applied by the government or used by the government, and how? And then the second question is more related to what Marta was saying. So how relevant and applicable these results are, or can we take those answers if people know that? Because I'm just asking this because it's part of my experiments on the creation of MPAs in Wales. One of the questions of the survey was how much did they know about MPAs, and 90% of the people, they had either never heard of MPAs before or they knew very little. So then I didn't
Okay. Marine protected areas. Okay. Let me take that point first. So the fact you've never heard of a marine protected area doesn't mean you don't value protecting the sea, right? Mm-hmm. Because you've heard of the sea. You've been to the sea, probably. You know something about the wildlife that lives in the sea. Never heard of a marine protected area is not necessarily such a big problem, because it just means what you should do is what is it that people understand about the good. I think the first study we ever did on the economics of biodiversity, which was, to say, a very long time ago, sure, when we our survey, what do you think biodiversity is? Very strange answers. But when we talk about the benefits of protecting biodiversity and where we talked about this as being animals you may have seen, animals you may but might still be important, then how is easier. So I think the fact they haven't heard of the name that you give it is not necessarily a big. Now, the problem with cold water corals is many people have not even experienced of this good at all. So that makes it really hard to estimate an economic value for. In some countries of the world, governments do use these kinds of numbers to make decisions. So, in the UK, we've got quite a long tradition now of people in the Ministry of Environment, for example, using these kinds of numbers to make real decisions about how to policy, whether to have a marine protected area. But in other countries that does not happen. So I think there's a very across countries of how these numbers are used, whether they are used at all. And finally, how much trust can you have in these numbers? Okay, so if I say the value of protecting the deep sea off the coast of Scotland, 3 billion, should you believe me? It's very hard to answer that question. I could say, well, it's 0. Or I could say, I did this study according to the best possible guidelines, most recent advice and research into how to design it properly, but I still can't tell you if this is the right number. Although it's better than a guess. And just finally, one of the first times we did one of these studies was to do with protecting traditional farmland in mountains in Scotland. And so the idea was to do this for environmental reasons, but also because there were these economic benefits. And so the Scottish government said, you go and measure these benefits for us so that we can figure out how much of this area we should protect. So this was 1997. Choice experiment in Europe. So we went and did this, estimated these values, and I said to the guy in the government, so if you create this area here, characteristics, then on average, the benefits are whatever it was, 20% per year. And he said, no, that number must be wrong. And I said, well, that can't be right, that number. I said, well, what do you think is the right number? He said, well, I have no idea. Your number's wrong. But he was just making a wild guess about the number he wanted to be. So at least in this case, we have some, and we do apply a lot of tests. And we can't say this is the amount of money you would take out of your purse and actually give.
No one really pays that.
No, that's true. And so, well, I mean, governments do costs in creating protected areas. Fisheries make less profit. Oil and gas companies can't explore here, so they. And we're trying to figure out, based on the theory that's underneath this, how much would you take out of your and give me for these dolphins? That's what I want to know, really.
What's the sample size of those choice experiments?
Vary a lot. So this one on Norwegian, because we were doing it in groups, so that was really, really expensive. We had about 50 euros each to come to the group, and we had groups with about 15 people each, plus the university people. So in the size is not large. I can't remember. It's like 300 or something. In the one on the Dogger Bank, it's a much bigger sample, because in these kinds of ones here, you can buy access to online panels, web panels from market research companies, €4 per address. Have 2,000, 3,000. In this here, this was smaller because it was his PhD. So I can't remember, 400. You can figure out statistically what's the people you need. But nowadays, the cost of doing this is coming down unless you're paying people to come to a room like this in Norway, in which case it's fortunately the Norwegian government were paying.
More questions?
They worn out.
In the example of the coral,
Yeah.
so to ask people, if you ask people how much they would coral reefs themselves, it's about the protection of. Did you ever split it up and ask how much they would pay for certain ecosystem services that deliver? For example, in the corals, it would be nursery grounds, but also all these different things. Would that make a difference for people?
We didn't do that. So we were just talking about how big an area and where, what kinds of areas. So would we avoid areas that were particularly good for oil and gas, or would we focus that were particularly high in biodiversity? But we didn't split it up according to what kind of areas. I mean, I think there is a problem with doing that in that you might be counting each benefit more than more than one time. So you might well double count benefits. So I mean, you could do it in a split sample way. You could say, well, these 500 people, I'm just going to tell them about the nursery fish production ecosystem service, and these 500 people, I'm just going to carbon sequestration. But that really just tells you about the context, I guess, and how that affects the value. So most of the estimates of the value of these use this production function approach. It's trying to say, okay, how much carbon is being sequestered and stored? What's the market price of carbon? How many extra fish are there to be caught? What's the market price of fish?
Yeah, I have another question. Because in two, I would think that more than just information about an ecosystem, information about costs or that companies make by exploiting it, for example, also really affect someone's willingness.
Yeah.
So maybe not only financial information as well about the context. So it could be something that could be interesting to include in a choice experiment.
You mean the cost to you or the cost to...
Yeah, different kind of costs. Maybe actual costs, so how much kind of subsidies are involved to make,
Yeah, I think all of these are aspects of the context.
Yeah, so instead of scientific context, providing more financial and structural context.
Yeah, I think we do that. And certainly people have experimented with changing how you pay. For example, a local tax versus a national tax, or changing what you tell people about who would lose. So in our case, that was the industry compared with the fishing industry. And in principle, that could affect your willingness to pay, although I'm not sure what, unless you actually work in the oil and gas industry or the fishing industry. These are just aspects of context, and I think we could change those and see what value, how that changes people's stated values. Because my voice is about to go. Make sure it's a really good question.
Do you think it would make a big... I know statistically might make it difficult, but instead of the choice of a few different prices, just let them give a value, just because like if you... for example, you might not choose the most expensive or
line, but goes somewhere in between. So if you give of 0, 5, or 10, they might go 5. I will pay something. Like, but do you think if you just left, would there be a big difference in give at the end?
Well, you couldn't do that in a choice experiment because you have to give levels to the price ticket. That's how it works. People used to do that in choice in contingent many years ago. You know, my first one, that's what I did. I just said, what's the most you're willing to pay to protect? And what we found was that people found that a very hard answer. It's a really tough question.
The first 3 levels the same, so to protect species you would pay 5, 10 or 20 and so on, like for the different levels.
Well, people do use something called a payment card, so that's where you have like, you say, okay, any of these could be the value, tell me the highest number that you would pay, or you could say, tell me which numbers you should pay and which numbers you are sure you would not, and maybe you leave some in the middle. And economics where we do that. So yeah, I mean, how you ask this question is really important. And what's important is people think there is a consequence of their answer. So if you do something which costs money, that there is some increase in the chance you're actually going to have to hand over your tax dollars and that you will get more marine conservation as a result.
The numbers you put there, in the value you're going to get in the end.
Well, size numbers here, whether I use 18 and 7, doesn't matter usually. We try not to use numbers that are too big so that everyone will say no, or numbers that are too small so everyone will say yes, because then we don't. But it turns out that the precise numbers don't really matter. What's really important is what you think will be the result from ticking here. Okay, I'm going to have to stop because my voice is...
Thank you.
Okay, thank you.
Okay, thank you very much to all of you attending this seminar. Thank you. Just telling you that there is a second seminar in 1 month at the beginning of May, so I hope you will come, and another one in June. So, well, I hope you will have also learned a lot from here. Well, and thanks for coming. Yeah. Okay.